The tank is the dominant weapon on the modern battlefield. One such tank is the T-62. This is a medium tank manufactured and used by the Soviet Union and other communist countries. Although a newer T-72 tank is being introduced into the Soviet Army, we can expect that the T-62 will be in Warsaw Pact forces for many years to come. It is quickly identified by its low-sloping turret, 5 large road wheels, and the bore evacuator 1/3 of the way back on the main gun. In this film, we will see how the T-62 operates. We will observe its capabilities, strengths, and weaknesses. We will see how it is employed in the offense as part of the Soviet combined arms team. And throughout, we will make comparisons with our tank, the M60A1. Finally, we will show how we can defeat the T-62. Now let's look at some characteristics of the T-62. It is a small tank when compared to our M60. It weighs about 40 tons and is only 8 feet high, about 3 feet less than the M60. Its low profile is partly due to its turret design. This, plus the compact size, give it a tactical advantage, particularly in the offense, since it presents a smaller target than does our M60. The turret traverses 360 degrees in about 20 seconds, slower than the M60's rate of 360 degrees in about 15 seconds. One problem with the T-62 is that the very low turret restricts the depression of its main gun to only 4 degrees. The M60 can depress its main gun 10 degrees. This -4 degree restriction is important because in a hull-down position, much more of a T-62 will have to be exposed before it can engage targets at or below the horizontal. This exposure makes the defending T-62 an excellent target for our anti-tank weapons. Warsaw Pact nations, however, do not consider this a weakness, as their tactics stress offense, not defense. The main gun is designed for fast-moving battles, characterized by tanks firing on the move or from short hauls. The T-62 has excellent mobility. It is powered by a diesel-fueled 580 horsepower water-cooled engine, and it is capable of speeds up to 50 kilometers per hour on a paved surface. The engine, however, in a particularly hot or desert environment, tends to overheat. To keep it cool, the louvers over the radiator on the engine compartment must be open. The open louvers make the engine more vulnerable to air bursts from artillery and mortar fire. The T-62 has a cross-country cruising range of 650 kilometers when equipped with auxiliary fuel tanks. Without them, it can travel 450 kilometers. The auxiliary fuel tanks will probably be emptied or dropped prior to battle. Another unique feature is a built-in air filtering system that permits the crew to operate in a chemical or nuclear environment without masking or wearing protective clothing. But there is some doubt about that system's effectiveness. For one thing, the T-62's automatic ejection system, when open, would permit nuclear radiation or chemical contamination to enter the tank. The T-62 is also watertight. It is equipped with a snorkel carried on the back of the turret until needed. The snorkel provides air to the crew and the engine. To install the snorkel and waterproof the tank requires from 1 to 2 hours of work. If the riverbed is firm and the current is less than 6 knots, the T-62 can travel underwater at a maximum depth of 5½ meters. The snorkel section above water is vulnerable to all types of fire. Another special feature of this tank is its ability to produce a smoke screen for up to 10 minutes at any one time. To make smoke, engine fuel is used. 10 minutes of smoke reduces the tank's cruising range by about 35 kilometers. In the offense, some T-62s will be equipped with mine-clearing attachments such as plows or rollers, shown here mounted on a US M60 tank. Both both attachments clear a path just wide enough for each of the tank's tracks. The backbone of any tank is its crew. Crew members are selected for their job position during basic training. The crew is composed of 4 men: a commander, a driver mechanic, a loader, and a gunner. Once assigned to a tank, they usually remain together for 12 to 18 months. This job stabilization gives the crew enough time to know their tank and be able to fight together with maximum efficiency. The crew is almost always available for tank-related training, and some kind of hands-on training is scheduled weekly. This may range from involvement in large-scale joint training exercises or be limited to the use of simulators. On the firing range, their tankers are taught multiple target engagements. Their tank gunnery ranges can display several moving or stationary targets simultaneously. The targets used on the training range represent various kinds of equipment and are positioned from 300 to 1,800 meters in depth. As they fire, the crews are graded on their ability to acquire the target, determine proper sight settings, and target engagement based on the degree of threat to their tank at that particular moment. Normally on these ranges, subcaliber ammunition is used, and standard ammunition is fired only twice a year. In all aspects of training, the tank crews are rigidly controlled and are taught to work closely as a unit. There are some characteristics of the T-62 that tend to degrade crew performance. Because of poor ventilation, the inside of the tank is extremely hot, and the low turret provides very little working space for the crew. The tank is hard to drive. The driver must operate 2 steering laterals, a mechanical clutch, an air assist clutch, and a 5-speed manual transmission. He tires easily, as do other crew members. After a period of time, crew fatigue will cause errors that may ultimately cause them to miss with their main gun. The major strength of the T-62 is the killing power of its smoothbore 115mm gun. Even when moving, those tanks equipped with a stabilized main gun have at least a 50-50 chance of a first-round hit on a stationary exposed target at ranges up to 1,500 meters. They prefer to fire on the move, providing immediate suppressive fires without slowing down the tempo of the attack. Another and more accurate method of firing is to move, make a short halt lasting 10 to 12 seconds, fire, and then immediately move on to reduce their own vulnerability. From a stationary position, the T-62 is very lethal. In fact, recent data makes it more impressive than original estimates. When halted, it has 2 out of 3 chances of a first-round hit on an M60 at 1,500 meters. But if our M60 is moving, it only has 1 chance out of 3 of hitting our tank. And when we are hull down, his chances of hitting us are only about 1 out of 4. Of course, when he stops to fire at us, our chances of hitting him are greatly increased. For the main gun, the T-62 carries a basic load of 40 rounds of ammunition, as compared with our M60's 63 rounds. The impact of this inequality became evident during the October 1973 Arab-Israeli War. On the Golan Heights, the Israeli tank units fought against a larger Syrian force. The Israelis fought with British Centurions and US M60s. Both tanks have about the same rate of fire and ammunition load. The Syrians fought with T-62s. A violent battle took place. Ammunition expenditures were very high. Finally, the Syrians retreated to the east. The Israeli success was due in part to their having enough on-board ammunition to keep firing for a longer period of time. The 40 rounds carried by a T-62 are a mixture of high explosive anti-tank, and hypervelocity armor-piercing discarding sabot rounds. The HE round is used to suppress or destroy our anti-tank weapons and thin-skinned vehicles such as APCs, and it is also an effective anti-personnel round. Both the heat and hypervelocity rounds are tank destroyers, but the hypervelocity round is the more accurate due to its tremendous speed. The hypervelocity round travels 5,300 feet per second, which is over 1 mile per second, making it the fastest tank cannon round in the world. The penetrator of that round is spin stabilized, and it can pierce and kill any armor that exists on the battlefield today. Although the T-62 has the fastest tank round in the world, the tank cannon itself has a slow rate of fire, about 1 shot every 15 seconds. The reasons for this are mostly associated with the functions of the loader. First, with the exception of 2 rounds in the ready racks, most of the ammunition is stowed fore and aft in the tank's hull. Second, due to the low turret, the gun, after firing at an angle below 3 degrees positive, must be elevated before the loader can place a new round into the breech. Third, the automatic ejection system disposes of spent shell casings through a port in the turret. This eliminates clutter, but it takes 6 seconds to complete the process and is much slower than our M60 ejection system. The combination of these adverse factors limit the rate of fire of the T-62 to only 4 rounds per minute. The M60 can fire 6 to 8 rounds per minute, almost twice as fast. The T-62's fire control equipment is good, but not as accurate as that in the M60. It has a stadiometric sight with 7 power optics. When employing the sight, the gunner has 2 techniques of target engagement. One method, not commonly used, requires use of the stadiometric rangefinder located at the bottom right of the sight. This rangefinder is based on a target 2.7 meters in height, about the average size of NATO tanks. To determine target distance, the gunner first fits the target tank between the upper and lower lines. This tells him the range. Then, knowing the range and type of ammunition he will fire, the gunner uses the upper scale to add the super elevation needed to hit the target. This process is slow and requires a highly trained and experienced gunner. Test firings with the T-62 have demonstrated that the accuracy of the Stadia rangefinder deteriorates rapidly as ranges approach 2,000 meters. Beyond 2,000 meters, the 7 power optics are relatively ineffective. The existing rangefinder limitation and the slowness are the most probable reasons that their tankers seldom use this method for engaging a target. Their most frequently used technique of target engagement is called grazing shot. This method is very similar to our battle sight gunnery. The gunner uses a predetermined elevation, which ensures that the round during flight does not exceed the height of an average Western tank. This technique is fast, and when using an APFSDS round, it makes the T-62 accurate out to about 2,000 meters. An additional problem for their gunner is that he cannot hold his sight and main gun on target between recoil and reloading. There are 2 reasons for this. First, after firing, control of the main gun is automatically transferred to the loader. Second, when the T-62 is fired at a target below 3 degrees, the main gun will automatically assume a slightly higher elevation after firing to permit reloading. This moves the gunner's sight off target and prevents him from applying the burst-on-target gunnery technique, that is, using the impact of the first round to adjust his aim for the next. During the time it takes to reload, the T-62 gunner can neither track the target nor traverse the turret. Of course, while reloading, the T-62 is extremely vulnerable to our tank cannon fire. In the T-62A version, the Soviets have added a stabilized gunner's sight. Its only added feature is that the T-62A gunner can adjust his sight in the vertical plane during reloading. Therefore, this sight is an improvement only when our vehicles are either stopped or moving directly towards their tank. The T-62 carries a 7.62 coaxial machine gun. It is used to suppress unprotected targets and troops in the open. Its effective range is about 1,000 meters, and its basic load is 3,500 rounds. The T-62A version has a 12.7 millimeter anti-aircraft machine gun mounted to the right of the loader's hatch. It is fired against all types of aircraft at slant ranges up to 1,000 meters. It has a basic load of 600 rounds. To fire it, the loader must be partially exposed, therefore vulnerable to our suppressive fires. Now let's look at the T-62 in the attack. It is quite possible that an attack will begin with a night move to a forward area traveling in march column. We can expect the T-62s to lead the way, followed by the BMP infantry fighting vehicles, and still farther to the rear, the BRDMs, wheeled armored vehicles, each carrying 14 Sager anti-tank guided missiles. For night moves, the T-62 will use infrared night driving and sighting equipment. This allows tank commanders to see 400 meters ahead, but the driver can see only 60 meters to the front, and their infrared lamps are active emitters that can be detected by some of our night surveillance devices. Before the battle begins, we will lay anti-armor mines on expected avenues of enemy approach. Or, by using a helicopter flying at 70 knots, we can lay 160 mines in only 21 seconds with the M56 dispenser. Near dawn, as the attacker is approaching our positions, we will engage him at long range using TAC air. Artillery, attack helicopters, and mortars. Somewhere between 3,000 and 1,000 meters from our position, the enemy will deploy from his march column to his attack formation. Shown here is a motorized rifle company reinforced with a tank platoon, T-62s up front. About 300 meters behind, the BMPs, spaced about 50 meters apart, and still farther back, the BRDMs. We can also expect to see the ZSU 23-4, which provides the enemy units with anti-aircraft support. Our helicopters are particularly vulnerable to this weapon. As soon as the enemy is at a range of 3,000 meters, we will begin firing our TOWs from well-covered and concealed positions. Our M60s, with their accurate fire control equipment, can hit him at those longer ranges. In the attack, the T-62 tank commander will be assigned a straight-ahead sector of fire. These sectors will overlap between adjacent tanks to avoid overlooking a possible target. These tactics are closely followed. As the tanks close to about 1,200 meters, they will begin to fire on the move. Now they want to suppress as well as destroy our weapons. In the attack, their tank tactics stress suppressive fire even more than they do pinpoint accuracy. Remember, the enemy will attack in strength, but because of his large numbers, he cannot take full advantage of cover and concealment. And to ease his command and control problems, he moves in fairly rigid tactical formations. Therefore, target acquisition will be easier for our tanks and other anti-armor weapons. As the battle closes within 1,000 meters, we can kill the T-62 with our very accurate anti-tank weapon, Dragon. Another way to slow his attack is to use our anti-tank fire to make his infantry soldiers dismount. This will slow the overall rate of advance, give us more time to engage his tanks, and make his dismounted infantry vulnerable to our artillery. At ranges of 200 meters or less, our infantry soldiers have a tank killer, the Law. To increase our hit probability, we will fire them in sequence or in pairs. In built-up areas, our infantrymen with Laws can fire down on the T-62 from upper floors of buildings. The T-62 is a powerful and effective weapon, but it has some vulnerable spots that, when hit by anti-armor fire, increase our chances of making a kill. When traveling head-on to you, it is particularly vulnerable here because the penetration round will hit ammunition or fuel or both. For flank engagements, and for the same reasons, it has two vulnerable spots: the forward and rear sections of the hull. For rear engagement, the engine is the best target for a mobility kill. A hit on the turret will probably knock out his main gun. The T-62 is a good tank. It is a formidable opponent. But we can beat it by bringing to bear the full weight of the combined arms team.